Physics, Part 424. A. In order to produce a large magnetic field through the patient must be placed inside a large cylindrical magnet. This can mean that the patient feels trapped. B. The total scan takes some time because separate scans of many slices through the patient must be taken. The patient must be very still whilst this is done, and this is difficult for children. Now it's your turn. During an MRI scan, the patient is placed in a large uniform magnetic field onto which the superimposed a highly calibrated, not uniform magnetic field. Explain the purpose of each of these two magnetic fields. Section Summary. Magnetic resonance MRI monitors the concentration of hydrogen nuclei in the body. Hydrogen nuclei have a spin which causes them to process in an applied magnetic field. The frequency of precession, Larmor frequency, depends on the magnetic field applied to the nuclei. A radio frequency pulse at the Larmor frequency causes the nuclei to resonate. On de-excitation, the nuclei give off radio frequency waves that can be detected and analyzed. Section question number 1. Explain briefly what is meant by the nuclear magnetic resonance. 2a. By reference to a nuclear magnetic resonance imaging, explain what is meant by number 1. Larmor of frequency. Number 2. Relaxation of time. Question 2b. Suggest with an explanation a typical value of the Larmor frequency. Exam style questions. Number 1. CT scanning and MR scanning provides images of section through the patient. A. Describe by reference to what is detected in each case, the difference between these two types of scan. B. Suggest why both types of scan rely on the use of powerful computers. Question 2a. By a reference of an X-ray image, explain what is meant by the sharpness and contrast. Question 2b. Describe how sharp X-ray images of soft organs such as the stomach may be obtained. Question 2c. The linear attenuation absorption coefficients of X-rays in muscles and in bones are 0.89 centimeter and 3.0 centimeter respectively. In a particular limb, a bone of thickness 1.5 centimeter is surrounded by muscle of thickness 3.0 centimeter, a parallel beam of X-rays incident on the limb. Calculate the fraction of the incident intensity that is transmitted through the limb. Question 3a. Describe the principle behind the use of magnetic resonance to obtain diagnostic information about internal body structures. Question 3b. Suggests 3 reasons why MR scanning would not be used to diagnose a simple bone fracture. Well, claustrophobia has just been mentioned when it came to MRI. Since the patient is trapped over there, it in fact creates a phobia within the patient. A patient trapped in the machine uh, is unable to move out, is frightened, and I don't think that everyone can withhold such a scan. If it comes to me, I don't think I would be able to stay in the machine for any limit of time. What to say of 30 minutes, I don't think I can endure even a single minute, even a few seconds. Because if I'm trapped there, well, on my own will, I can stay as long as a full night, but if I'm trapped there, I won't be able to do it even for a few moments.